Okay, good evening, ladies and gentlemen, and welcome to this live session today. And it's going to be a what you can say kind of a continuation of what we have seen in on the last Saturday. Okay, not Saturday, I think Monday. Chalo, let's begin. So, what topic? Yeah, before that, let's welcome the new members in the community, in the team. Anybody new here attending the live session first time? Let me know in the chat box quickly. If you are attending this first time, uh, just type me in the chat box. If you are, yes, okay, Mr. BM Sharma is there. Who else? Who else? Who else is the new member here? Type in the chat box quickly. Okay, a lot of new members are yet to join. Okay, sure. Everybody just type welcome new members in the chat box, and let's start our journey. Welcome, 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 Mr. Sharma, and whoever is the other new member. I think there are a lot of new members yet to join. Yeah, Sandeep is here. Okay.
Thank you, sir.
Welcome, welcome, welcome. Okay, chalo, let's start the journey. So, what topic we are going to discuss today? Type in the chat box. Very interesting topic, by the way. Very interesting. So, we are going to touch the basic and advanced both today. And I hope everybody, the new people especially, has got Minitab downloaded. If not, no worries, you can do it later. So, you just have to observe them. Okay, if you don't have, yes. Capability analysis. No, it is not only capability analysis. Yes, it is six-pack capability analysis. Huh? So what is six-pack? Something interesting we are going to learn today. Okay. So before that, let me just go back to my whiteboard. All the new members are requested to take the notes. Okay. And the notes are there to for our references so that you guys can refer them in the future as well. Okay. Now we will have the question and answer session at the end of the session. So whichever doubt you have, just make a note of the doubt, and we will have the Q&A session later. Okay. Before we close the session, we will have open Q&A session. You can unmute yourself and ask the question. Okay. Fantastic. So no, it is not like first topic of the green belt, but this is the green belt topic. Okay. Now the topic which we are discussing, it's called process capability. Okay. Now, how many of you were there last Monday? Just type me in the chat box. How many of you were there last Monday? Kon tha? Type in chat box. Okay, lot of people were there, right? So we also discussed process capability last Monday, if you remember, correct? So we discussed about a discrete process capability. Today we are going to discuss about a continuous process capability. Are you understanding? Yes. So you can take see the holistic picture. And for the new members, I will show you where you can check the recording of the last Monday session. And don't worry, everything is a part of the green belt curriculum only. Okay. Shayanji, just understand, just observe whatever we are doing. I will answer all your queries. Okay, na? Ye green belt ka hi class hai, don't worry. Yes. Very good. Okay, make sure that you are muted all the time when you are here. Because sometimes when you're traveling, it can get unmuted. Okay. Now the topic which we are discussing here is process capability. Okay. Now process capability in DMAIC framework, write this down in our DMAIC framework. We do it 2 times. Okay. Make a note of this. We do it 2 times. One is in the measure phase, which is before improvement. Write this down. Before improvement, and one in the control phase, which is after improvement. Write this down. Right? Why do we do process capability? First of all, just try to understand what is process capability. If you remember, in our yellow belt also we spoke about 4 sigma level, 5 sigma level, 6 sigma level. How many of you remember that? The first, the new people especially. Oh, great, Tanmoyji. Fantastic, fantastic. So this will be kind of, revision for you, as well as six-pack analysis is a little advanced as well. Okay, so that will be additional for you. Chalo, so how many of you remember the new people? This the 4 sigma, 5 sigma, the table I showed you. Just type yes in the chat box if you remember that. Remember that? Exactly, yes. So that 4 sigma, 5 sigma, 3 sigma, that is nothing but a process capability. That number 3, 4, 5, 6, that number is that process capability number, which we are going to actually identify today with the help of Minitab. Are you clear? And why do we do that? First of all, why do we do that? Very simple reason behind that is comparing whether you have improved your process or not. Let's say you are at 3 sigma process before the project starts. After improvement, if you have reached to 4 sigma, 4.5 sigma, so there has to be some improvement in that number, and that is something is process capability. Yes, CP, CPK, all those things are the same thing, which we are going to discuss today. Clear here? So process capability, have you understood? The definition of the process capability, simple definition is, write this down, ability of the process, write this down, ability of the process to satisfy customers' requirement. Simple definition. Everybody, write this down. Ability of the process to define, or to satisfy customer requirement. Clear hai? Ability of your process to satisfy the customer requirement. For example, your customer wants delivery of the product within 30 minutes, like pizza delivery, right? Pizza, 30 minutes are free, correct? So your customer wants delivery of the product or whatever service you are offering within 30 minutes. If you can deliver within 30 minutes, that means your process is capable to deliver within 30 minutes. If you cannot deliver within 30 minutes, then your process is not capable to deliver within 30 minutes. Are you understanding this? Yes. And we will collect the data and how many processes, how many times you can achieve your target within 30 minutes. And that number, what we are going to calculate, it's called process capability number. Are you getting some idea what we are talking about here? Just type yes in the chat box. And it is applicable to every industry, whether it is manufacturing, service, banking, IT, BPO, every industry applicable. Your ability to deliver within the requirement of the customer, that's it. That is called process capability. Okay. Now, when we collect the data, you clear here? So I'm just make sure that you are taking the notes. Okay. Now, when we collect the data are of 2 types. When you type in the chat box, what are the 2 types of data? If you attended the last Monday session, you would definitely know this answer. There are 2 types of data. New people, please make a note of this. 2 types of data. When you collect the data, there are 2 types. What are those? Yes, very good. Continuous and discrete. Absolutely right. Okay. It will either be continuous data or it will be discrete data. Or it will be discrete data, right? So whether it is continuous or discrete, what is continuous? The data which is measured on continuous scale. Data which is measured on continuous scale. Here the discrete data is, it is counted and it cannot be measured on a continuous scale. Second point, can be expressed in decimals. Write this down. So expressed in decimals. Decimals. Second, you cannot express discrete data in decimals. because they are whole numbers. Example, height, weight, pressure, temperature. For example, 1.1, 1.2, 1.3 meters, 1.4 meters, 1.5, 1.9, 2, 2.1, 2.2. It's a continuous, I can measure it on a continuous scale. It is called continuous data. On the other side, discrete data example, male, female, go, no go, pass, fail. How many pass, how many fail? Yes, no, accept, reject. Are you understanding? These kinds of data are called continuous data. Or there are other types like genders, like colors. Are you understanding? So you can count the number of colors. How many number of colors are there in the rainbow? So you can count the number of colors. So it is counted and not measured. See how we can basically speak as well, right? We measure the weight. We don't say count the weight. Understand this? So see the difference, huh? And we never say go and measure how many number of people present in the room. We say go and count in the number of people present in the room. When we say count, it is a discrete data. When we say measure, it is a continuous data. Are you clear with this? Just type yes in the chat box. Are you clear with the simple differentiation? Super clear hai? Okay. Very good. Now, for your understanding, just for better depth, in-depth understanding, in your process, just go back, reflect back in your process and give me one example of continuous data if you have, and one example of discrete data if you have in your process. With this example, these are common examples. Now you go back to your process and just try to reflect. Okay, this is a continuous data. We are measuring this. Okay. Fantastic. So temperature. Now, whenever you are writing this, type C for continuous and put D for discrete. Okay. So that will be clear so that you have understood this. Okay. So temperature is continuous data. Number of transmitter is a discrete data. Fantastic. RH is what? Continuous data. Okay. Temperature is continuous data. Number of transmitters. Okay. Pressure is continuous data. NPS कौन सा डेटा है? डिस्क्रीट कंटिन्यूस है. NPS is a continuous data. Okay. Type in chat box, everybody. Try to reflect. Dimensions are in continuous. Number of defects are in discrete. Discrete. Number of rejection. How many parts rejected? Discrete data. Fantastic. Super. Are you clear with this? Just type yes in the chat box. Clear hai? Continuous, discrete. Anybody has got any kind of doubt in your mind? Clear? Now, when we have continuous data, understand this. When we have continuous data, we do process capability with z-score, write this down, or CP/CPK value. What is that? We are going to discuss. And when we have discrete data, we do process capability in DPMO or PPM. Clear? Write this down. So when you have continuous data, go for Z-score or CP/CPK. When you have discrete data, go for DPMO and PPM. So it depends on what kind of data do you have in your process. How are you collecting the data? Is it in the form of continuous? Is it in the form of discrete? If you have discrete, go for DPM or PPM. If it is in continuous, go for Z-score and CP/CPK. Clear hai? So we are going to discuss about continuous data. Okay, this one. Today we are going to cover this part. And last Monday, we had covered the process capability of the discrete. And for the new people, I will explain you where you can check the recording. You can check the recording in Masterclass Archive, where you will find last Monday recording. You can go through it. So this is this week's homework for the new people. please check the recording of the discrete process capability analysis, which is DPMO and PPM, which is there. All right. Okay. Are you clear with this? Just give me yes in the chat box. Okay. Just give me yes, everybody, new people, senior people, everybody. Clear, cool. Yahan tak cool hai. Very nice. Super. Amazing. Now, so let me clear this. So if you want to take a screenshot of this, you can do that quickly. Done? Very good. Very good. Very good. Chalo. So let me share a Minitab file with you. And on that Minitab file, we are going to work today. Okay. Let me share a Minitab file with you. If you have not downloaded Minitab yet, just observe what we are doing. And at the end of the session, for the very new people who have just joined maybe yesterday, and if they don't have the Minitab right now, I'll explain you how to download it. Okay. So till the time, just observe. So just this is one file I'm doing. I'm just sharing. If you have the laptop in front of you, the laptop or the desktop with Minitab installed, you can download this file. Okay. This is a common file which we are using for our green belt as well. The chocolate wala weight wala file. Okay. Chalo. So once you have opened the file, let me know in the chat box. Okay. Just type open in the chat box. File name is process capability normal. If you can download it from the chat, you can just click on that and get downloaded. No, only this is only one file. All the three files, because few people may not get because they're traveling, etc. It's the same file, only same file, shared size. Okay. Just open this file, click on that, it will get downloaded, and just open that. Once it gets opened, just type open in the chat box. Okay.
Sir, I'm logged in through mobile. That's why I'm asking so that I can
Mobile
download it from that looking folder.
मोबाइल में Minitab open नहीं होगा. You require some desktop or the laptop. Yeah.
No, no, sir. I want to download it from that looking folder. That's why I'm asking the name.
Just to see. So you can go to एक मिनट मैं बताता हूँ. If you have the green belt curriculum, no, okay. In the green belt curriculum, there is a file called. Let me tell you the name of the file. Okay. Yeah, the file name is normality test. That in
Okay.
that you will find the same file. Okay.
Okay. Okay. Thank you, sir.
So there could be multiple files, but you can just chocolate weight. Okay, normally it is chocolate weight. Okay, that file you can
Normally it is chocolate weight.
chocolate weight. Okay, that file you can download. Anyway, chalo, downloaded, opened, everybody. Very good. Chalo. So let's understand what is this file all about. So this is a chocolate company data. Now they have the chocolate weight collected. Now, for example, let's understand this. So their quality control person, his job is to check the weight of the chocolate, and accordingly they are accepting or rejecting the product. Okay. Now you need to tell me chocolate weight is continuous data or discrete data. Type in the chat box. Chocolate weight is continuous or the discrete data. Yeah, you require the Minitab software downloading. If your software is not downloaded, just observe what we are doing. Okay. You can do it later. No worries. Just observe what we are doing. So chocolate weight is not discrete data. It is continuous data. Again, chocolate weight. Just see there now. Do we measure or we count chocolate weight? See, the question may he answer hai. Do we measure chocolate weight or we count chocolate weight? We measure. Whenever we measure the weight, it is a continuous data. Understand this? And it is depicted in the decimals, no? 42.1, 42.2, 42.3. So on a continuous basis, when it is expressed on a continuous basis, it is continuous data. Are you understanding? Very simple logic. If it is on a continuous scale, it's a continuous. Just let's say your length. So we use the scale, no, to measure the length. On a continuous scale, we measure, right? It's a continuous data. So 10.1, 10.2 centimeter, 10.3 centimeter, 10.4 centimeter, 11, 11.1, 11.2, 11.3, 12, 12.1, 12.2. So on a continuous scale, we can measure. It's a continuous data. Are you clear? So chocolate weight is a continuous data. Now, in this company, they are checking the chocolate. So let's say I am the quality control person and my objective is if the chocolate weight is less than 40, I will reject it. Like that. Okay, that is what my role is. Now, what they have done is, so their standard is they take not one chocolate at a time, they take 10 chocolates at a time. You can see here. They have taken sample 1 as 10 chocolates. Can you see? So first chocolate is 42.1 grams, 40.7 grams, 40.3 grams, 42. So similarly, they have collected 10 samples with them, 10 samples. Okay. Similarly, after maybe 1 hour, they have collected another 10 samples. Okay. How many of you are from the quality? Just type me in the chat box. Quality mein kaun hai? Then the third sample. Yes, a lot of people. Okay, fantastic. A lot of people are there from quality. So you also take the samples, no? After a defined frequency, you also collect the samples. Correct? Now understand this. Similarly, they have collected 10 samples. Now, how many samples totally they have collected? So they have collected 12 samples like this. So 12 samples, total 120 chocolates they have. Every sample 10, in every sample there are 10 chocolates. Are you clear with the data? Are you clear with the data? Just type yes in the chat box. Clear hai? Data samajh mein aaya? So we have 120 chocolates with us. And every time after 1 hour, they have collected 10 chocolates each. Okay. Now, so before we go and check this process capability, there are 2 steps we need to do. Always remember this. The first step is called stability of the data. What is stability? Stability, yes, SNC, fantastic. You guys are very smart now. Huh? Stability, what is stability? Stability is nothing but whether the process is within control or not. And that is done through control chart. Are you understanding? Yes, exactly. So SPC, statistical process control. So control chart is a very, very important part of statistical process control. So what do you mean by control, stability or control chart? Now, according to Walter Shibert, who is father of statistical process control, no problem, no problem. Just observe this. We will figure it out. Just observe this. This is very, very important. Walter Shibert is father of statistical process control, statistical quality control. According to him, if any process runs through plus or 3 standard deviation, that process within plus or through plus and minus 3 standard deviation, that process is called as stable process. I'll explain you this very simple. We will do this so that you can understand it. Okay. What is plus and minus 3 standard deviation? It's very simple. So if you collect the data like this, chocolate weight. So first chocolate is 42.1, second chocolate is 40.7, third chocolate is 40.3, fourth chocolate is 40 point, whatever it is, right? So everywhere, so this graph will be plotted. right? So we used to plot the graph, during our school days, right? On a graph paper. Similarly, a graph will be plotted. After that, there will be average will be taken for this, and then we will have to plot a x bar. X bar is nothing but the average of all the data points. And after that x bar, the average is plotted. There will be two lines will be plotted, and we need not to plot it. Software we have Minitab software with us. So software will plot that line. So those lines are called upper control and lower control limits. Okay, and those lines are upper control is x bar plus 3 times standard deviation of whatever data you have, and the lower control is x bar minus 3 times standard deviation we have. Yes. So right now I'm just explaining basics. So let's not discuss about n is equal to 12 as of now. Okay. I'm just mixing. So let's consider sample size is 1. All the samples are independent samples. Okay. They're multiple. So okay, let's do this. Do this basics. What you can say basic control chart, and then we will understand it. So first do this stability. Okay. Then I will explain the concept. So what we will do is, let's do this. Go to stat, control chart, variable control chart for individual and individual. Let's do the first basic control chart करके देखते हैं. Stat control chart, variable control chart for individual and individual. Everybody just follow this path. Stat control chart, variable chart for individuals, individual. Once you reach here, click on individual. You will come to this, window. Okay. Here you just have to select chocolate weight. That's it. Double click on chocolate weight. It will get selected. Double click on chocolate weight. It will get selected. Okay. And just say okay. Don't do anything else. And you will get this graph. Everybody got this graph? It's a basic control chart. This is called as individual control chart or eye chart. You can see here the name called eye chart. I stands for individual. Mind blown. So now this will be very regular for you guys. Okay. It's called eye chart, individual control chart. Everybody got it? Just type got it in the chat box if you have got this. If you have the Minitab right now with you, yeah, I'll repeat the step. How many of you got this? As of now, how many of you got this? Yeah, after stat, let me show you the steps once again. Stat, control charts. Okay, let me just first remove this. Go to stat, control chart, variable chart for individual, individual. Just follow this path. Stat, control charts, variable chart for individual, because we are considering individual data points and individuals. Okay. Now, once you click on this individual, okay, let me remove this. Then this will appear. Click on this variable. There will be this box of variable. In that, double click on chocolate weight. Just double click on that. It will get selected. Once it got selected, just click on OK. That's it. Just click on OK, and you will find this graph. Now, got it, everybody? Just give me yes in the chat box. Super. Now, this is the graph I was talking about. So every data point is the chocolate weight, and there are 120 chocolate weights plotted. Then they calculated the average, which is 42.106. Okay. Then they have calculated UCL and LCL. Can you see here? UCL and LCL. If you remember the formula I gave you, X bar plus 3 times standard deviation becomes my UCL, and LCL is X bar minus 3 times standard deviation becomes my LCL. Okay. What is important is, within this variation is called as, write this down, common cause variation. And any data point which is going beyond this control limit, like for example, this data point is exactly just touching the control limit. Just like if a batsman hits a six and that that ball hits the boundary rope like that. Okay, so this data point is exactly at control limit. So this data point is called as special cause variation. I'll give you example for this. I'll give you example for you go to office every day, right? There is always a variation, common variation, 5 minutes, 10 minutes early or late you reach. Let's say 9 o'clock is your time target, but sometimes you reach 8:50, 8:55, sometimes you reach 9:05, 9:10. Yes or no, everybody? There is always a common pattern of your traffic or your travel or your whatever. These are common, normal things. And that common variation is called common cause variation. It's a common cause variation. But one fine day, there is a big accident on the road, or one fine day, your tire gets punctured, and you reach maybe 1 hour late to office. That is called special cause variation. How many of you got this? Common cause is routine variation. They are very small variation, and special is big variation. The moment you have 1 hour delay, that is called special cause variation because there is a special cause attached to it. Got it, everybody? Have you understood this? Now, if the process has only common causes, then the process is called a stable process. If the process has got special causes as well, then the process is not stable. Okay. UCL stands for upper control limit. LCL stands for lower control limit. Write this down. UCL stands for upper control limit and LCL stands for lower control limit. Clear, Ham? Everybody? So are you clear with the basic fundamental of stability? Yes, assignable cause and special causes are absolutely same. So assignable means you can assign the cause, no? That is called it is assignable cause. Are you understanding? When you can assign the cause, okay, why did you come late by 1 hour? You can assign the cause. Okay, my car got punctured, or there was some technical issue to my car. That's what I got late. So I can assign the cause. But if you ask the question to the common cause, you will not get the answer. Are you understanding? For the common causes, you will not get the answer. If you ask me, why are you late by 2 minutes? It's a common variation. Utna to late hota hi hai. Utna to variation hota hi hai, right? It's a common variation because of traffic, because of, your all variation, small variation every time. It's a common variation. Clear, everybody? Just like yes in the chat box. Are you clear? Super clear? Now, in this case, this is a fundamental thing. Okay. Now, in this case, let me just remove this. Okay, let's take a screenshot of this, by the way. Let's take a screenshot before I remove this. Common cause, special cause. एक बार screenshot ले लो if you are taking the screenshots. Okay. Fundas पहले clear कर लेते, then we'll go to stability check. Okay. Now, done. Very good. So, here, because our data is different. Now, how do we go back to the data from this graph? How we go back to the data? Look at this. So here, observe this area where I've just made a circle. Okay. So this is the tab for the graphs. Whatever graphs you are making, it will be stored in this tab. You can click on the tab, you will get all the graphs. Okay. This is for the data. On the left-hand side of the graph, there is a data tab. If you click on the tab, the data will appear again. And this is for all statistical analysis. This is called a sessions folder. Sessions folder. This folder, you will show you all the statistical analysis you have done. Now, as of now, we are doing the graphical analysis. So we will not go for sessions folder. Let's go to the data now. Just click on the data. How you click that? This tab you have to click. You just go for the data. Now, there are various types of control chart. And whenever we have the sample, Okay, the subgroup sample, like in this case, there are 10 chocolates we have taken, right? So group of samples we have taken. Are you understanding? So whenever we are taking a group of samples, generally we go for X bar R chart, write this down, X bar R chart or X bar S chart. What is X bar? X bar is average and R is range. Range. Here X bar is average and S is standard deviation. Okay. So when do we use X bar R chart? When the sample size, when in a sample, if you are collecting less than 10 units, go for X bar R chart. And if your sample is having more than 10 units, go for X bar S chart. Are you understanding? If less than 10, go for X bar R, more than 10, X bar S. See, you can commonly use X bar S directly as well. X bar S is always better than X bar R. Always remember this. Clear hai? So this is, so the control chart which we have seen is a basic control chart, the one which we had drawn earlier. Now this one is the control chart we should be using because we are not taking individual samples, we are taking the group of the samples. Are you understanding? Yes. So X bar R chart is X bar is the average and R is the range of the data, and X bar S is the X bar is average again and S is standard deviation of that. Now let's understand is what does it mean. Now here let's take the first sample. Let's take the first 10 samples. Okay, these are the first 10 samples. So the X bar meaning software will calculate the average of these entire 10 data points. Are you understanding? Just focus here. Now just focus here. Software will calculate the average of all these 10 data points. So this one be X1 bar, the first group of sample ka average. Everybody clear with me? Just type yes in the chat box. Super clear? Okay, X bar. Okay. Now what is R? R is called range. What is range? Maximum value minus minimum value. So it will calculate what is the maximum value here. For example, let's say here is 43.1, I believe, right? Yes, 43.1 is the maximum value here. And what is the minimum value? I think 36.9. So maximum value minus minimum value is called the range. So software for the first sample will calculate X bar, which is the average, and the range, which is the maximum minus minimum. Are you clear? For the first sample, it will calculate one data point for average and one data point for range. Are you clear? Just type yes in chat box. Focus करो ये. यहाँ पे very simple है. This is very simple to understand. Clear? X bar are clear? Same goes with the second sample. Same goes with the second sample. It will calculate the average of second sample and the range of the second sample. So actually we are plotting two graphs here. The first graph is for the average graph and the second graph is for the range graph. Okay, so that's why it is called X bar and R chart. Similarly, instead of range, if software calculates standard deviation, and standard deviation is called as S. S for sigma, standard deviation. So that is called X bar S chart. Okay. X bar S chart. So it will be calculated X bar in one graph, and instead of range, it will be calculating the standard deviation. It will plot on the graph. And this is called X bar S chart. Are you clear? So instead of range, if you replace it with standard deviation, that will be called as X bar S chart. And we will do X bar S chart now. Clear है? हम लोग करके देखें on Minitab so that you will understand it very clearly. Super clear? Very nice. चलो, so let's understand this. Let's go for X bar S chart now. इसको let's take a screenshot of this before I just wipe it off. X bar and X bar S. Okay. Standard deviation is the there is a formula of standard deviation. I'll show you the formula of standard deviation. Okay, it's an average deviation from the mean. Okay, we look करके देखते हैं, that will be easier for you. So let me, yeah. So let's go to stat control charts, variable chart for subgroup X bar S. Everybody just follow this sequence. Stat control chart, variable chart for subgroup X bar S. Write this down. आप अपने नोटपैड में ना लिख लो ये stat, then arrow, control chart, arrow, variable chart for subgroup, arrow, X bar S. इस प्रकार से मैं नोट निकालता हूं so that it remains. And in your curriculum, we have given you the screenshots as well. Okay, so step-by-step screenshots are also given so that you can easily navigate through this software. Okay, it will be easy. Plus live sessions में हम लोग live करते हैं तो that will increase your confidence as well. Okay, and then whenever time permits, you just do this practice. Start the recording of this and just pause this recording and just follow the instruction and do it on yourself. Okay, with yourself so that your confidence will grow. Okay, chalo. Click on this X bar S. Here, you just have to click chocolate weight in this region, and in the subgroup size, select sample. Everybody, in this, select chocolate weight, and the subgroup size, select sample column. And click on OK. That's it. Don't do anything else. Just click on OK. Just type OK. And this is X bar S chart for us. Just type got it if you have got this graph. Got it, everybody? Now try to understand this. Try to understand this. As I mentioned to you, just try to read this graph. Read this point, first point. This point is the first 10 chocolates ka average hai. Okay. This point is X1 bar. This point is X2 bar. This point is X3 bar. X3 bar meaning X bar is the average. Average of the third sample, it's called X3 bar, X4 bar, and so on and so forth. Similarly, this point is standard deviation of the first sample, S1. This point is standard deviation of the second sample. This point is standard deviation of the third sample. This one is standard deviation of the fourth sample, and so on and so forth. Are you clear, everybody? From the same data, one, it is calculating the average. Second, it is calculating the range. Now, the standard deviation. Now, both are basically measuring two parameters. If I draw this kind of structure, average is this, right? The center. So X bar is basically finding out the center of the data, and standard deviation is basically denoting this variation. How much is the spread of the data? Are you understanding? Both are measuring different characteristic of the data. Got it? So X bar is measuring the central tendency, and the standard deviation is measuring the variation of the data. Clear? Yes, ye clear ho gaya, everybody? Yes. Now, only thing we need to do is we need to just check whether any data going beyond control limits. Is there any data going beyond control limits like this? Like this? No, right? All the data points are within the control limits, yes or no? Yes, X bar is the average of the first 10 samples. Correct? This is average of the first 10 samples. This is standard deviation of the first 10 samples. This is the average of the second 10 samples. This is standard deviation of the second 10 samples. Okay. So now, by seeing this graph, we can say that the process is stable process. Yes or no? With this X bar S chart, we can declare the process stable process. So before process capability, we have to do first stability. So this is the first check is done. Stability is done. Okay, positive. Okay, very good. Now the second step is we have to do the normality. Go back to the data now. Go back to the data. So clicking on this tab, we are coming back to the data. Now we have to check the normality of the data. Okay. What is normality? Go to stat, go to basic statistics. Just follow this sequence. Same data, boundary line, data point 1 becomes stable because the control limits are separately calculated in both these cases. X bar R के लिए separate है, X bar S के लिए separate. मैंने वो basic आपको दिखा दिया था. Remember, I showed you the fundamental basic chart, but ideally you should have done X bar S chart because it's a subgroup sampling. There is sampling involved. You should go for X bar S chart. Okay. I just to showcase the the basic parameter, I just went for the individual control chart. Okay. Yeah. Chalo, so go for basic statistics, and in the basic statistics, go to normality test. Okay. Go to normality test. Stat basic statistics normality test. Stat basic statistics normality test. Just click on normality test. This window will appear. Just select chocolate weight. Just select chocolate weight over there and just say OK. And you will observe this graph. Everybody got it? Just type got it in the chat box. Stat, basic statistics, normality, the third last option. Stat, basic statistics, normality test. Just select the chocolate weight in that and just click on OK. That's it. Don't do anything else. Okay. Yeah, but have you got the Akhil Ranjan ji? Have you got this graph? एक बार ग्राफ ले लो, मैं आपको एक्सप्लेन करता हूं. ग्राफ आ गया आपको. Just follow the sequence. That's it. Stat, basic statistics, normality. Done. Now, just try to understand this. What is this graph all about? There are two statisticians, Anderson and Darling. Anderson, Darling. There are two statisticians. One is called Theodore Anderson. The second one is called Donald Darling. And these two statisticians basically discovered this test of normality. Okay, that's why it is called Anderson-Darling normality test and or AD test. You can see here AD. Now here you can see first it is a mean, which is the average of the data point. Okay, it is a standard deviation, which is sigma of the data point. This is n, which is the number of data points. Okay, number of data points, number of data. Then AD. Now there is a calculation to calculate the AD value, but for us AD value does not make any sense. For us, this value has got a lot of meaning, which is called p value. Okay. So now this graph is made on the x-axis. It is the chocolate weight. On the y-axis, there is a percentile of the data. Okay. Now let's not get into the detail. I will explain you later. Right now, what is important is if the p value, write this down. If the p value is, this p value is greater than 0.05, then the data is normal. Write this down. Normal meaning normally distributed, like this, symmetrical, normally distributed data. If the p value is less than 0.05, then the data is non-normal or skewed distributed, like this. For example, it would look like this. This kind of data is called skewed distributed data. Skewed, एक तरफ झुका हुआ data. Are you understanding? It is not normal. Normal meaning symmetrical data. And this is called a skewed distribution, skewed data. Are you understanding this? Just type yes in the chat box. So right now tell me, is the data normally distributed or not? Is it normal with the p value? Is it normal? Just type yes or no in the chat box. Yes. So the p value is greater than 0.05. It is greater than 0.05. No. The p value is 0.256. So which is absolutely greater than 0.05. So we can say the data is normally distributed. Another hint we can get is if the data is non-normal, No, the data would look like this. Okay, there would be some data points which will be away from this line of significance. This is called line of significance, this red line. And there will be some data points will be scattered around this. Some data points will be away from this line of significance. But as of now, these data points are very closely, tightly bound with the line of significance, and that this is also indication that it is normally distributed data. Clear hai? If the p-value, we say that the data is normal or not, then what is the importance of AD value? Does not have any importance for us. From the AD value is a reference value. From the AD value, p-value is calculated. So to calculate p-value, we require AD value calculation. Are you clear? Yes. For us, AD value does not have any meaning, but for us, p-value has got nothing. Okay, clear? So what we have done here is, for both these data, I'll go back to the data now. So what we are discussing here, first we have checked stability. First, we have checked stability with the control chart. Yes or no? Control chart. So this is the control chart we have seen, correct? And then we have done normality, correct? Normality with Anderson-Darling normality test, right? So it looks like this test and the p-value which is greater than 0.05. Everybody done? And now we are ready for capability analysis. Okay, now we are ready for capability analysis. So how do you remember this? How do you remember this? So P stands for probability value. Okay, when we will learn hypothesis testing, we will go deeper into understanding of probability value. Okay, P value. We'll do manual calculation as well, how P value can be calculated. Okay. Making the same data normal or skewed, normal test. So if the data is normally distributed, the p-value will be greater than 0.05. If the data is skewed distributed, the p-value will be less than 0.05. Are you understanding? So it depends on the data, whether the data is normal distributed or not normal distributed. Okay, it depends on that. Now, so how do you remember this? You remember the sequence S, N, C. Always remember this. Before we calculate the capability of the process, what is the sigma level? 2 sigma, 3 sigma, 4 sigma. First you do the stability, then the normality, and then the capability. Okay, so remember the sequence SNC. Everybody just type SNC in the chat box and write this down. SNC, stability first, normality second, then capability. SNC, remember this sequence. SNC. Now we will do capability analysis. Okay, stability we have done, normality we have done. Let's do the capability analysis right now. So how do we do capability analysis? Go to stat, quality tools, capability analysis, normal. Just follow the sequence. Stat, quality tools, capability analysis, normal. Why normal? Because the data is normally distributed. Stat, quality tools, capability analysis, normal. Okay. Once you click on that, everybody just click on that. In the single column, select chocolate weight, double click on chocolate weight. In the subgroup size column, select sample. Just follow this. Single column, select chocolate weight, and subgroup size column, select sample. Now for the process capability analysis, we require our specification limit, right? We require specification limit, whether the data is capable or not, the process is capable or not. To check that, we require a standard, right? We require process, what you would say, specification limit. So in this case, write down the lower specification limit in this case is, let's say, 36, and upper specification limit is 48. Just put this data over there. So that means what we are saying is we will accept the chocolate between 36 gram and 48 grams. So 38 to 46, 36 to 48 is our limit, specification limit. Everybody got this? So in the single column, select chocolate weight, subgroup size, select sample column, lower specification is 36, upper specification is 48. Don't click on OK yet. There is a small change we have to do. Go to option column. On the right hand side, there is a tab called option. Just click on option column. This will open. Over here, just see my cursor. Here you have to select benchmark Z score. Benchmark Z. Just click on that and say OK. I repeat again. Go to option here. Select benchmark Z. Just click on benchmark Z and say OK. And say OK. You will find this. Just got it? Everybody got this? Just type yes in the chat box. Everybody got it? Super. Now this is your process capability. You can see here. When your Z bench is 3.46, this is my, so that means when my Z bench score is 3.46, so this is my 3.46 sigma process. This is my current process capability. Yeah, this is a 3.46 sigma process. And we have so see when I say 6 sigma, understand this, huh? When I say 6 sigma, this 6 is the Z score. Write this down. And the sigma denotes our standard deviation. Write this down. So 6 denotes capability and sigma denotes variability. And in Six Sigma, in Lean Six Sigma, what we are doing here is we are reducing the standard deviation to improve our Z score. As standard deviation will reduce, our capability will improve because process will come closer. The variation will come closer to the target, to the center, and our process will become more capable. So Z score is that number. That number is that Z score. Are you clear? How many of you got this? Just type. How many of you got a bulb on moment right now? Just type BO in the chat box. Lot of bulb on moments right now which are happening. Simple hai. Lot of bulb on moments. Yes. First time we are doing this. Simple, mind blowing. Super. Now, sir, but you were saying something about six-pack analysis. What is six-pack over here? Is this analysis called six-pack? No, this is not called six-pack. You remember S, N, and C? What if I can do S, N, and C analysis in one click? And that magical is called six-pack analysis. Let me show you that. Okay. First, you take the screenshot of this. So this is called, see, this is called before improvement process capability. Okay. So right now you are at 3.46 sigma. After improvement in the control phase, you will do the same analysis and it should be maybe 4.56 sigma or maybe 5 sigma kind of thing. Are you understanding? So this should improve. That Z score should improve after improvement. Are you understanding this? Just type yes in the chat box. Yeah, Z score is Z score. When I say 6 sigma, again repeat, I repeat this piece, okay? Just observe, this is very, very important understanding. When I say 6 sigma, the 6 number is a Z score number. When I say 6 sigma, the Z score number is that 6 number is the Z score, which is showing the capability of the process. And when I say sigma, is denoting the standard deviation, which is denoting the variability. Okay. So it is a combination of Z and sigma, 6 sigma, Z score and sigma number. Clear hai? Take a screenshot of this. Now let me show you the process the six pack analysis. Okay. Now let me just clear this off. Go back to the data. I'm coming back to the data. Now in the stat quality tools, below the capability analysis, which we have just done, there is something called capability six pack. Can you observe this? Stat quality tools, capability six pack, and normal, because our data is normal. Just click on that. Okay. Just see this stat quality tools, capability analysis, capability six pack. Click on this normal. Now put all the data as it is, whatever we have done. No, same process यहाँ पे भी follow करना है. Go for chocolate weight. Sample subgroup size is sample. Lower specification is 36. Upper specification is 48. Go to options and select benchmark Z. Okay. Yes. And click on OK. And click on OK. And abracadabra. Here we go. This is called six pack analysis. Now you can observe this over here. This is this part. It's called stability S. This part, it's called normality N. And this part, it's called capability C. So stability, normality, capability in one shot, it is called six pack analysis. Just type MB in the chat box. Mind blown. In one shot, you can do it. But if I would have explained you this would have been a complete bouncer to you. So I have to go step by step. First, I have to go to stability. So the same thing, X bar S chart. हम लोगों ने already किया है. Okay. This is histogram, which we have done in the process. This is normal probability plot. Anderson-Darling normality test. See the p-value over here. AD value and the p-value. Okay. Now this is something new, which is called a dot plot. ये dot plot क्या है? Same data points. All the data points are plotted. Okay. For example, this is sample number 1. So sample number 1, all the 10 dots are plotted. 10 samples are plotted. Second sample, 10 plotted. So we can see the variation of each and every sample in this dot plot. Okay. This is the only advantage we get. But apart from that, we can see here 3.46. This is my Z bench. So my process is 3.46 sigma process. And this entire thing is called six pack analysis of process capability, which is used for the continuous data. Done. So what is the homework? The homework is take your own data. If it is continuous data you have, do this stability, normality, and capability of the data. And if possible, share with us. Okay. Share with us on our email ID, or you can share it us with on this number. Okay. I'll just give you that number, which I believe everybody must be having this. Okay. Just save this number, everybody. Plot within and overall. So within and overall is nothing but, see what is within and overall. So this is, for example, let's understand this. When we go back to, let me go back to the data. Okay. So what is within? If every sample, within the sample itself, there is a small variation. If I plot this sample, no? Okay. Let's say this sample, there is a small variation over here. Then I will plot a second sample, there will be a variation. Third sample, there will be a variation. Fourth sample, there will be the variation. Fifth, so every sample, there will be the variation. So this is called within variation. And what if I collect all the 120 samples together and calculate the standard deviation? That is called overall standard deviation. Are you understanding? So within is within each and every sample, and overall is overall each and overall all the 120 samples together. That is called overall. Clear? It's called within and overall. Six pack instantly. I will do it once again. So go to stat, go to quality tools, capability six pack. Just below the capability analysis, there is a six pack. Go to normal. put the data in, okay, and say, okay, you'll get a six-pack analysis directly. Yes, fantastic. So it requires the practice, right? So you collect the data and do this analysis and share the screenshot and your learning, on our WhatsApp number, on our email ID. Okay. And if there is some correction required, we will suggest you, and so that your confidence will grow up. Okay. And check this recording multiple times. This will be available in masterclass archive. Okay. Let me just type this masterclass archive over here. Masterclass archive. Okay. Now it will be available in your, yes. Now, how do you improve your sigma from 3.46 to 5? And this is your DMAC project comes into picture. Okay. So you have to basically reduce the variation by using DMAC. So you go to fishbone, why there is a variation. Okay. Why the chocolate weight is having a lot of fluctuation. So you identify man, machine, method, mother nature, material, all the causes. Then you identify the root causes. You validate the root causes with hypothesis testing regression. Okay, you take the action on them. And by doing all the stuff, you will reduce the variation. And as the variation reduces, your Z-score will improve. Are you understanding this? Yes? Clear head? Z-score within is more sigma than Z-score overall. Means less variability within the subgroups. Yes, you're right. Absolutely right. So the standard deviation within, if the standard deviation within, let's understand this. Don't look at the Z-score. I'll share with you. Let me go back to the data. So let me plot it once again. Okay. So you can see standard deviation within, which is 1.618, and standard deviation overall is 1.64. So there is no much significant difference between within variation and overall variation as of now. To check the variation, we have to go for standard deviation. To check the capability, we have to go for Z-score. Clear? In this case, GRR is required. No, GRR has to be done before that. Okay. गेज आर एंड आर हम लोग पहले करते हैं, उसके बाद में डेटा कलेक्ट करते हैं. कैपेबिलिटी एंड में होती है. प्रोसेस कैपेबिलिटी द लास्ट स्टेप इन द मेजर फेज. अंडरस्टैंड दिस? ओके. So gauge R and R before that we do. Okay. So I will take gauge R and R separate session. So you will understand practically how the gauge R and R is conducted. Okay. And in the Minitab also we'll do that as well. Okay. In our hackathons, green belt, black belt hackathons, we do this practical as well. Okay. So I'm just open for any question you have. I'm open for that. So how do we do, right? We raise the hand. You have to raise your hand so that